I'm making this video because recently I've been answering this question a lot, and it's a bit of a shame because I have hinted certainly at this answer in other videos, never directly, but certainly it's been hinted at. And it arises from that video that I made on belief and truth. And the problem arises because of our concepts of truth. If we believe in truth, then there's only one way of doing something. It must be right, it must be wrong, it must be black, it must be white. It's only one truth. And that's an unfortunate view, because that view also leads you to the idea that there is only the best way of doing something. So I frequently get asked, what's the best way of making graphene oxide? What's the best battery? What's the best way of making a supercapacitor? And all of these kind of questions are actually meaningless. If you take lithium, for instance, lithium's a great material. Wonderful, huge energy density, fantastic batteries they make out of it. What's the problem? Well, the problem is that if we swapped every car in the world to electric cars on lithium-ion batteries, there's just not enough lithium in the world to do it. So it's not the best for making car batteries, not because of power density, because there just isn't enough of it. And this is why so much effort goes into looking at other materials, not because those other materials are better, but because those other materials are more abundant, so we can all have some. So when you're asking really what is the best, if you take that out of context, it becomes meaningless, because the best material in terms of power density is probably lithium. But the best material to make a battery from probably isn't lithium if we're going to supply everybody. It's probably something like carbon or iron or aluminium or magnesium, something like that. It depends what your conception and your definition of the problem actually is to what the solution is. Even then, it wouldn't be the best. It would just be appropriate to the solution that you've just stated. So if you're looking for the best of something, the chances are you really haven't put your problem into proper context. Now, it also leads to another idea. That is the idea of something can only be one thing. It can be either right or wrong or black or white. If it's not that, it must be something else. And this has arisen recently because I've been doing quite a lot of work on solar cells, supercapacitors and batteries, and particularly batteries. Now, the problem really arises that there's a difference between the ideal and the real. So here's a battery. Only an idiot would argue that that is anything other than a battery, because we all recognise it as a battery and it's got a huge label on it saying battery. So we think, yeah, there's a battery. That performs the function of a battery. But if you think about what's actually in there, it's two pieces of metal separated by an insulating membrane. Sure, that membrane is microporous or nanoporous, but it's insulating. So that setup is actually a capacitor. It is without a doubt that there is an element of capacitance in there as well as an element of a battery. There are other things in there as well. Because it's a real thing, it also has an element of resistance in there. So in that battery, the one that we label battery, there's actually a combination of effects. There's a battery effect, there's a capacitance, there's a resistance, there's a whole host of things going in there. So why is it we call it a battery? Well, we call it a battery because the predominant effect, the overriding effect, the thing that gives it its bulk qualities that we can recognise are the qualities of a battery. So we label it battery. But actually that doesn't make it a battery. It makes it a combination of things where battery is the overwhelming effect that we have. Now this is true actually of most passive electronic components. And I've got a little selection of electronic components here. It's a resistor, it's a capacitor, and that's an inductor. Now when we look at those things and we put them in our circuit diagrams and we work out the maths involved in them, we deal with them as ideal components. That is, we only think about the capacitive element to a capacitor. But a capacitor, being two plates separated by an insulating material, also is a real thing. So there's some resistance in there. And actually, because it's two plates, there's also a bit of inductance in there as well. So each of those components can in fact be modelled this way. So what we have here is a capacitor, a resistor, and an inductor. And this is a standard model. Actually, it's slightly different. There's actually a resistance here for the leakage current. But we'll ignore that for the moment, okay? If we take our capacitor, then in that capacitor, because it's real, there's an element of resistance, an element of inductance in it, to actually model the behaviour of the capacitor. Now this bit is our ideal capacitor. That's the bit we only ever consider when we're looking at a capacitor as an idea. When you get a real capacitor, like the one I showed you, you have to pay attention to all these other elements in there as well. And that builds that component, or that model of the component, to give you a good description of the real behaviour of a real capacitor. When you're looking at the ideal capacitor, you look at that bit. So when we look at a real capacitor, which is actually made up of these three passive components, what bit is it that makes it a capacitor? Well, what makes it a capacitor is that the capacitive element of it outweighs the inductive and resistive element of it. Equally, if you take an inductor obviously is a coil of wires laid quite close to each other with an insulator in between. Inductors have capacitance in them. It's a coil of wire, so it also has resistance in them. An inductor looks just the same. So what is it when we look at an inductor? Well, the inductive component is the bit that outweighs everything else, so that it becomes an inductor. So these passive components are essentially the same three things. What makes it an actual component is the element that we're interested in outweighs the factors that the other elements bring into play. Now, most of the time, this doesn't really matter very much. It matters in high frequency on the inductance, because very often the capacitance can exceed the inductance when you do that. Then the parasitic capacitance can outweigh it so much. In fact, your inductor becomes a capacitor, because this element outweighs this element, but all elements are always present. So take that idea away with you and think about it for a minute. There is no ideal capacitor. Capacitors are real things, so they contain everything. And you have to sometimes think about everything. Let's have a think about the structure of a battery, a supercapacitor, and a solar cell. We've got a plate of some kind, usually metal. Plate of some kind, usually metal. It can be other things, it can be carbon, it can be anything at all, separated by some kind of insulating separator. And essentially, that's the layout of a capacitor. Now, a battery is just the same. It's a plate of material, separated by an insulator, and there's usually an electrolyte in there. There can be electrolytes and capacitors as well, incidentally. So a battery and a capacitor look the same. Now, oddly enough, a solar cell looks very similar. Usually, this one's transparent to light, so when the light hits it, the active material responds, and we get a current flowing between these two plates. So solar cell, capacitor, and battery look very, very similar in terms of their structure, so it should be no surprise at all that they share very similar behaviours. What makes them a battery, supercapacitor, or solar cell is that one set of factors will outweigh another. So if we take a battery, for instance, then any energy input we put into there is going to improve the battery performance. So if we increase temperature, then we're going to get more power out of it for a shorter time, obviously, because we've got a fixed amount of material in there, but we're still going to increase the amount of power that we can get out by putting in temperature. If we probably, I've not tried this, but probably if we increase pressure, we're going to get exactly the same effect. And other factors that we put in there, if we shine a light on it, particularly infrared obviously, because that's going to be temperature, we're going to get another effect in there that's going to improve the power output. So all of these things are going to have an effect, but the effect is going to be moderated by the particular setup that we're actually using. So let's say, in the same way that we're talking about passive components, that every single capacitor, battery, or solar cell actually is the same thing. And that when you look at a device that could be a capacitor, battery, or solar cell, you're actually looking at something that contains all three elements, but what defines it as a capacitor, battery, or solar cell is which element outweighs all of the others. So if I get something you recognise as a battery, just like that battery I showed you, there is without a doubt a capacitive effect in there. It's probably an element of solar in there as well. I mean, solar heats the thing up, so probably an element of that in there. These are going to be relatively insignificant. They're going to be tiny. That is going to be the predominant factor. Now, we call it a battery, not because it's only one thing, and it absolutely truly is that one thing. We call it a battery because that is the predominant effect that actually takes place. All of the other effects definitely take place, but that one is the predominant effect that takes place, and the one that we notice, and therefore the one that we call it a battery. We stick that label onto it. So why are we talking about this? Well, we're talking about this because I've had quite a lot of people finding it difficult to grasp the difference between a battery and a solar cell, particularly in light of the experiments that I've recently been doing. A lot of people writing to me saying, there's an element of battery in there. Now, it's very difficult to argue against such things because in one sense, of course, it's perfectly right. There is an element of battery in there, but there's an element of battery in it, all of this stuff. So you can't really say, no, there isn't, it's just a solar cell. You have to think, well, yes, that's very true, there is. But then, of course, in another sense, they're totally wrong. And what it betrays is too rigid a view of things. They're just being too rigid. And they're being too rigid mostly because of the idea that we have only one truth, that they're brought up in this Western way of thinking when it can only go down that one line. So it is either a battery or a solar cell. If it contains an element of battery, therefore it can't be a solar cell. Well, that's just nonsense. And I hate to say that, really, because it is just nonsense. It's a question of context. Now, I had one lad write to me, and he said he'd taken the particular design that I'd done, he'd stripped it of the electrolyte, taped together the two pieces of metal and dropped it in some ordinary tap water and got 0.4 of a microwatt out of it, or it might be 4 microwatts. Anyway, he got 4 microwatts out of it. The experiment I showed was 32 microwatts out of it. So have a bit of sense of context here. What is the difference between 4 microwatts and 32 milliwatts? So it's milliwatts. Well, the difference there is actually 9,000. So maybe 1/9,000th of the contribution to the power output of that particular setup was battery. Yes, maybe it was. But does that make it a battery? Well, no. 1/9,000th is insignificant. Now, when I was a kid, I come from quite a large family, actually. There's about 8 of us in the family. And in our tradition, at the end of the meal, we had a chocolate biscuit to finish off the meal. It was just what we did every time. And we used to eat this particular style of chocolate biscuit where it came 8 to a pack. So that was just totally convenient. 8 of us, 8 to a pack, 1 chocolate biscuit each, meal finished. Unfortunately, one year they decided to change it and make it 9 to a pack. And that was really irritating because at the end of the meal there was this chocolate biscuit sitting on the table. And my father said, okay, let's cut it into 8 and we can have an 1/8 of this chocolate biscuit. And a bit of biscuit was tiny, it was like that. And everybody looked at their 1/8 of a biscuit and said, don't worry, forget it, I don't want it. And so my father had the whole biscuit because nobody else wanted their 1/8. It was ludicrous. Now imagine how ready you would be to have your bit of biscuit had it been 1/9,000th. It would have been a crumb. So, a little bit of context here. There's bound to be an element of battery involved in any solar cell or any capacitor, and equally an element of capacitance. But in contextual terms, it's 1/9,000th of the contribution. It's so tiny, it hardly even bears thinking about. But because of our conceptualization, that if it's not this and only this, ergo it must be wrong, it's just a nonsense conception. You need to be slightly less rigid in your view of things, and a little more adaptable maybe. If you don't want to be if you don't want to be slightly less rigid, well, of course, that's your own privilege. I don't mind. And the guy wrote to me saying, look, you haven't got me convinced. And I thought, well, he's missed the point. Because I'm not peddling you snake oil. I'm not trying to convince you of anything. I'm just telling you things that I'm doing, things that I think. Being convinced or believing something or making up your own mind, well, that's not my responsibility, that's your responsibility. You think about things and you make your own mind up. I'm not busily trying to convince you or sell you snake oil. Just telling you what I'm doing, telling you what I think, you make up your own mind. If you can't make up your own mind because you're a bit too rigid, well, it might be time to look at your rigid views. Anyway, there's my thoughts on being too rigid and supercapacitors. I hope you enjoyed watching, and thank you very much.